without using mathematical table or calculator. So for m, so you have the logarithmic equation here. So look at the left hand side, look at the right hand side. So the first thing you're going to identify is when you look at the right hand side, there's something here that you can simplify this one. And before you solve this question, ensure that you are aware and you're familiar with the basic laws of logarithms, because those are the ones that you're going to use in this question. So the left hand side, I don't see whether there is anything to be simplified, but the one that I have already underlined, that is a third logarithm of 8m raised to power 6. This one you can simplify to logarithm of 8m raised to power 6, everything raised to power a third. And this one will simplify to further when you look at this power third, look at the bracket. So this means that 8 has to be raised to power third, and m raised to power 6, you have to raise those two numbers to power third. So we start with the first one. What is 8 raised to power third? 8 raised to power third will give 2. So you get 2 for that. And then m raised to power 6, m raised to power 6, you raise that one to power third. This one will give m squared. Remember, this is power. M raised to power 6 raised to power a third. So this will give m squared. So you can see how I've done it. 8 raised to power third is 2. M raised to power 6, you raise that on to power third, you get m squared. So after we've done that, the other thing that you're going to do in this question, look at 2. 2 is the only value that is not expressed in terms of logs. So we're going to write 2 in terms of logs to the base 2. How do we do that? This is how we do it. We simply take logarithm to base 2 for number x, because we don't know that is supposed to give 2. So therefore x will be 2 squared, and that will be 4. And therefore logarithm 2 can be expressed in terms of logarithm as logarithm of 4 to the base of 2. So once we've done that, now we can write our equation. So we have on the left hand side logarithm of this 3m minus 4 is equals to this will be logarithm, this is 2, we have already simplified this one to 2m squared, then minus 2 we have written that one in terms of logarithm to be logarithm of 4. Again, on the right hand side, using the laws of law of subtraction, logarithm, we can express this one as a singular logarithm like this. So this will be 2m squared divided by 4 as a singular logarithm. So now we have that logarithm of 3m raised to this is 3m minus 4. So once we've done that, you can see we have logarithm on both sides of the equation. The next step is to drop the logs from both sides, and when you drop them, you will have 3m subtract 4 is equals to 2m squared divided by 4, like that. So once you've done that, I can multiply each term by 4. I can multiply this one by 4, this one by 4, and this one by 4. And this one will simplify to 12m. That will simplify to 12m minus 16 is equals to 2m squared. When I look at these values, it is possible to divide all through by 2 to simplify this. You can divide everything by 2. So this will give us 6m minus 8 is equals to 2m squared. The next step from there, you can see this one is going to form a quadratic equation. So we can reorganize these. And this one is m squared. Sorry, this one will be m squared. Once we divide these, this will be m squared when you divide all through by 2. So when you reorganize these, you will get m squared. Take 6 to the other side to be minus 6m. Then take minus 8 to the other side, it will give plus 8 is equals to 0. So that is a quadratic equation. You can solve that using any suitable method. I'll use factorization. So I'll look for two numbers whose product is 8 and sum is -6. And those numbers are 4, -4 and -2 to be -4 and -2. So -4 and -2. So using factorization method, I'll have m squared. So m squared minus 4m minus 2m minus 4m plus minus 2m, that is -6m plus 8 is equals to 0. So what is common here? M minus 4 minus 2, m subtract 4 is equals to 0. So this will give m subtract 2 multiplied by m subtract 4 is equals to 0. And therefore we shall have two values of m. The first one, m minus 2 is equals to 0. So for this case, m will be 2. And when m minus 4 is equals to 0, here we shall have m to be 4. So those are the two values of m. Given that 2 cosine of 2x minus 30 degrees is equals to -6/5, find x where x is greater than or equal to 0 and it is less than or equal to 360. So given the range of the angles you're supposed to get there, x should between that range 0 degrees and 360. So the first thing you're going to do is to make sure, because you want x, you're solving for x, look at the left hand side, 2 cosine of 2x minus 30. You have to eliminate everything there and remain with x. So I'll start by me write the equation first. So we have 2 cosine of 2x subtract 30 is equals to -6/5. So I'll start by eliminating 2, dividing both sides of this equation by 2. The left hand side I'll get cosine of 2x subtract 30 is equals to, when you divide the -6 of you simply need to multiply this one by a half, and this will give 6/10. So this will give -6/10, which is -0.6. Get -0.6. Then from there, there's something I want you to note here. The negative. What is the meaning of this negative that is here? -0.6. And you're working with the cosine. So when you draw the circle, trigonometric circle, we draw it here. When you draw this circle, we draw it properly. So this is what you're going to use. So if you look at this circle, and I will indicate all the quadrants, the negative implies where cosine is negative. Where cosine is negative. So it will help us to identify in which quadrants do we have cosine being negative. So on the first quadrant, all of them are positive. That is sine. When I talk of all of them, it is sine, cosine, and tangent. All of them are positive. Then the second quadrant, only sine is positive. The third quadrant, only cosine is positive. Not cosine, but tangent. Only tangent is positive. And then the last one, only cosine is positive. Now that negative implies, where do we have cosine being negative? In which quadrants? The second quadrant and the third quadrant. That is where we should get our angles. Because the second quadrant, the only thing that is positive there is sine. All the others are negative. The third quadrant, only tangent is positive. All the others are negative. So after getting that, now when you are getting the cos inverse, because now you have the left hand side cosine of 2x minus 30, if you want to remain with 2x minus 30, you get cosine inverse of cosine of 2x minus 30. You will remain with 2x subtract 30 degrees is equivalent to get the cosine inverse. But this time around, you're going to ignore, when you're getting the cos inverse, I'll write it here, get the cosine inverse of 0.6. Don't take the negative. The negative was only to help us identify where we're going to get these angles being negative, the cosine. And we have identified cosine will be negative in the second and third quadrant. That was the meaning of that negative. So when you're getting this angle, simply now, because you have established where the cosine will be negative, just take the cosine of cos inverse of 0.6. And this will give, so 2x subtract 30 degrees will give, so this one will give 53. Cos inverse of 0.6 will give 53.13 degrees. So now this is the angle that you're going to use to find the angle in the second quadrant and in the third quadrant. So that acute angle will help us to find those angles. Now using that acute angle, let's get, for example, the angle in the second quadrant. So in the second quadrant, this is how we get the angle. In the second quadrant, we take 180 degrees, subtract 53.13. So the angle there will be 126.87 degrees. So that is the first angle in the second quadrant. What about in the third quadrant? In the third quadrant, where we found the cosine will be negative, the third quadrant, we take 180, then we add that acute angle 53.13 degrees. These will give 233.13 degrees. Now, those are the two angles. Now, when I look at this range, and when you equate all these, because you're supposed now to indicate all these angles, you're supposed to now take 2x minus 30 is equals to 126.87. Then you solve that. Then you take 2x minus 30 is equals to 233.13. You solve that. And when I look at the range 0 to 360, we can go to the second round. The second round. What do I mean by the second? The first round, you start from 0. This will be 90. This will be 180. This will be 270, and this one will be 360. If you go the second round, now you shall have this one is 360 plus 90. This will be 450. Then 450 plus 90, this will be 540 degrees. 540 plus 90, this will be 630. And then you go to 720. See, you can go the third round, the fourth round. You try to get until all the angles that you require are in the range given. So now the second round. So let me go to the second quadrant. The second quadrant, but now not the first round, but the second round. The second round. What will be the angle? So the second round, remember, it is 360 plus 4 plus 90, you get 450. So in the second quadrant, the second round, the angle will be 540. So I will get 540 degrees. Then I subtract that acute angle that I'm using, 53.13, and this will give me the angle as 486.87 degrees. Then we go to the third quadrant. The third quadrant, second round. The third quadrant, second round, will be given by 540 plus 53.13, and this will give 593.13 degrees. So those are the angles. So we have those angles. If we go to the third round, I'm seeing as if this one will exceed the range that is given. So we can first test and see the angles that you're going to get. So now from our equation, we have the angles as follows. So now we have 2x subtract 30 degrees is equivalent to 53.13. We are not taking that because that is in the first quadrant, and in the first quadrant all of them are positive, and remember we want quadrants where cosine is negative. That is why we're just using 53.13 to help us get the angles in the other quadrants. So the first one that we got was here 126. So we have 126.87 degrees, and then we have this one as well, 233. We have 233.13 degrees, and also we have 486.87, and then we have 593.13. So now to get the value of x, this is what you do. So 2x subtract 30 degrees is equals to 126.87 degrees. So for x, x will be given by 126.87 plus 30 divided by 2. So 126.87 plus 30 divided by 2. So x there will give 78.44 degrees. That is the first angle. The second one, 2x subtract 30 degrees is equals to 233.13. So here we will have x be given by 233.13 plus 30. You divide by 2, and that will give 131.57 degrees. We take the other one. Now the other one is 2x minus 30 degrees is equals to 486.87 degrees. So x again will be 486.87 plus 30 divided by 2. This will give 258.44 degrees. Let's go to the last one. You see 2x minus 30 degrees is equals to 593.13 degrees. So here x will be given by 593.13. We add 30, and then you divide by 2. So that will give 311.56. These are 57 degrees. So you can see all those angles by looking at the last one, 311. If we go to the third round, probably we are going to exceed the range, that is 360. So therefore, the solutions for x will be given by, the first one is 78.44 degrees. The other one is 131.57 degrees. The other one is 258.44 degrees and 311.57 degrees. Make k the subject of the formula. So you can see where k is. So the first thing you're going to do is to cross multiply. You can cross multiply both sides. So we take this one as this is a t over 1, and then you cross multiply like that. So t, so we shall have t multiplied by nk squared minus n is equals to 1 times, this will be m minus p k squared. Opening the bracket, we get nt k squared minus tn is equals to m minus pk squared. Now look at where we have k's, so we can combine these, you can take them to the same side. K is there, so we can bring them to the same side, so that I can bring this one on this side to have n t k squared. When I bring negative pk squared to the left hand side, I'll have p k squared is equals to m. I can take negative tn to the right hand side to be positive tn. Then the left hand side, k squared is common, so you can factor it out. You remain with nt plus P, like that, is equals to m plus Tn. Then from there, you can divide both sides by to remain with k squared, because that is what you want to make the subject. I can divide nt plus p. I divide by this nt plus p, both sides. But let me first work it out like this. So k, so I have k, then nt plus p. I divide these by nt plus p is equals to m plus tn. I also divide this one by nt plus p. So by doing so, I will have k squared be given by m plus tn divided by nt plus p. You want k, not k squared, so what do? To remain with k, given k squared, you get the square root of k squared, you get k, and then the other one, you get the square root, you'll get positive or negative of m plus tn divided by nt plus p. So that is what you do. To get k, you simply get the square root of both sides. So now we've made k the subject. The length and the width of a rectangular sheet of paper measured to the nearest millimeter are 22.3 centimeters and 15.7 centimeters respectively. Calculate to 4 significant figures the percentage error in the area of the paper. Now, how do you get the percentage error? Begin from there. How do you get the percentage error? So percentage error will be given by absolute error in the measurement given, and in this case will be the absolute error in the area of that paper, divided by the actual area multiplied by 100. So from this formula, we need therefore to have the absolute. How do you get the absolute error when we are getting the area of this paper? It will be given by, so absolute error will be given by half into brackets maximum area minus the minimum area. That is how you're going to get it. So therefore we need to get the maximum area and the minimum area, and to do that we shall use the limits. So look at these are length and the width are given to the nearest millimeter. Should be careful with that. And the length, so therefore the length, we have the length and we have the width. So the length is 22.3. So the smallest unit of measurement is 0.1. So absolute error in that measurement will be a half times 0.1, which will give 0.05. In both of them, they are measured correct to nearest to a millimeter. That is correct to one decimal place. So the absolute error in each of the measurements will be 0.05. So therefore, to get the limit, like for example for length, you're going to get that by adding the limit. So it will lie between, you have to add plus or minus 0.05, like that. The width the same, 15.7, to lie between that 0.05. So when you are getting the maximum area, because this one is a rectangle, length times width, so we are going to get the maximum for length, and the maximum for length we are going to get it by 22.3 plus 0.05. that will give 22.35 centimeters. Then the maximum for the width, it will be given by 15.7 plus 0.05. that will give 15.75. So that is what we need to multiply. When you multiply that, you will get 352.0125. These centimeters squared. Then we get the minimum. So the minimum area will be given by, we are going now to use the minimum for each of these measurements. For the length, this is how you get the minimum. 22.3 subtract, you want to get the subtract 0.05, that will give 22.25. Then the minimum for the width, so we get 15.7 subtract 0.05, that will give 15.65. And this will give, when you multiply, you get 348.2125. So we can now subtract maximum area minus the minimum area. You can subtract it from here, and when you subtract these, you realize it will give 3.8. So therefore the absolute error in calculation of the area will be a half multiplied by maximum minus minimum. We have already subtracted, you got that as 3.8, and this will give 1.9. So that is the absolute error, 1.9. Now after getting that, we need now to get the actual area. So how do we get the actual area? The actual area, we get it by using the original measurements the way they are without having to interfere with them. So the actual length is 22.3. The actual width is 15.7. And when you multiply these, you get 350.11. So that is the actual area. Now we can proceed and get the percentage error. The percentage error will be given by the absolute error, which you got as 1.9, divided by the actual area, which is 350.11 multiplied by 100. Supposed to give correct to 4 significant figures. So this will give 0.5427%, correct to 4 significant figures. Expand 5 plus x divided by 2, everything raised to power 6 up to the term in x raised to power 4. So the first thing we're going to do is to write down the coefficients of power 6 using the Pascal's triangle. And the coefficients are 1, 6, 15. You use Pascal's triangle to get these. The power 6 is 20, 15, 6, and 1. Those are the coefficients. Then now we can start the expansion. The first one will be, the coefficient is 1, so 1 multiplied by, that will not make any difference. So we have 5, 1 times, can just put it there, 1 times 5 raised to power 6. 5 raised to power 6. Then multiply by, you multiply by, the second term is x divided by 2. This one we start from power 0. Power 0 like that. Then we add, we go to the second term. Second term we have the coefficient as 6. Then multiply by 5 power 6. This one will keep reducing, so it will be 5 raised to power 5. Then multiply by x divided by 2. And then this one will be to power 1. Note that this one will continue increasing. And then we go to the next one. The next one, the third term will be, the coefficient is 15. 15 times 5 raised to power 4. You can see 5 began from power 6. It is reducing, then power 5, then power 4. The second term starts from power 0. Then it increases to power 1. So now it will be power 2, like that. We go to the next term. The other coefficient is 20. 20 multiplied by 5 raised to power 3, and then multiplied by x over 2 raised to power 3, like that. We're still going on. We want to go up to where we have the power, the term in x raised to power 4. So you can see here, x divided by 2 raised to power 3, that is going to give us x up to x raised to power 3. So you have to continue with the next. So plus, the next one will be, the coefficient is 15, the next coefficient is 15, multiply by 5 raised to power 2 times x raised divided by 2, now raised to power 4, and that is where we are going to stop. Why do we stop at that point? Because that is where we shall get the term in x raised to power 4, x over 2 raised to power 4. That is going to give us whatever we require. So now this is what we need now to simplify. We need to simplify all these. And when you simplify these, you simply multiply each one of them. So the first one will give 5 raised to power 6. X over 2 raised to power 0 will be 1. So this one will remain with 5 raised to power 6, which will give 15. 15, 6, 25. Then plus 6 times 5 raised to power 5 times x divided by 2. When you multiply that, you get 9375x. The other term, 15 times 5 raised to power 4 times, using a calculator for this, times x over 2. X over 2 squared will give us x squared divided by 4. So that will give 9375, then x squared divided by 4. And then the next one, 20 multiplied by 5 cubed times x over 2 cubed. X over 2 cubed will give x cubed over 8. And that will give 625 x cubed divided by 2. And then plus 15 times 5 squared times x over 2 raised to power 4. And that will be x raised to power 4, 2 raised to power 4 will be 16. This will be 375 x raised to power 4 divided by 16. Like that. So that is the expansion. You can leave it in form of a decimal. It will still be correct. Part 2. Use your expansion to estimate the value of 11 over 2 raised to power 6 correct to one decimal place. Now to work out these, you have to split these down. So 11 over 2 raised to power 6 is the same as 11 over 2 is the same as 5.5. 5.5 raised to power 6, which is the same as 5 plus a half. Remember this binomial expansion, so you have to break this one into two terms. So 5.5. So that is how you're supposed to write it. Then this is how you use that expansion. Remember the expansion that you are having was 5 plus x over 2 was 5 plus x over 2 raised to power 6 is equals to, you equate this one because you want to use that expansion, equate it to this 5 plus a half raised to power 6. So when you look at this, just look at what we have here. Just look at what you have there. Everything is similar apart from, so you're going to take this is equals to this. So x over 2 is equals to 1 over 2. All the other terms are uniform, 5, 5, power 6, power 6. And this one will give 2x is equals to 2. This will give x is equals to 1. So now the moment you get x is equals to 1, you use this expansion here and substitute. So you have 15, 625 plus, then where we have x, just substitute with 1, so 9375. So x there is 1. And then plus 9375 divided by 4. So here you have 1 squared. It will not make any difference. 625 divided by 2. And then we have x cubed. X is 1. Then plus 375 divided by 16. X is 1 raised to power 4. Like that. Do not make any difference. Do not make any difference by multiplying by 1. So use a calculator to work out these. And when you use your calculator, 1526 plus 9, 9375, 90 plus 9375 divided by 4. Feed everything in the calculator, and then you're supposed to give the answer correct to one decimal place. You will have 27,679.7 correct to one decimal place. That is what you're supposed to get, 27,679.7. A quantity P is partly constant and partly varies inversely as the square of t. P is equals to 6 when t is equals to 6, and P is equals to 18 when t is equals to 3. Find t when P is equals to 11. This is partial variation, and this is how you're supposed to solve this kind of a question. Now, we write this equation first. A quantity P is partly constant. The constant I'm going to use is A. And partly varies inversely as the square of t. So before you write inverse of t, you have to indicate the other constant. You must have two constants here. Then divided by, because it is inversely as the square of t, so square of t is supposed to be like that. So that is how you're supposed to write that equation. A quantity P is partly constant, that is A, and you add partly varies as inversely as the square of t. So you put the constant of variation, that is B, then inversely, you know, that one is going to be down there, so divided by t squared. So A and B are referred to as the constants of variation. Now, given that P is equals to 6, we can substitute P is equals to 6 when T is equals to 6. So both of them are 6. So you have constant, you don't know it, then call the constant, then this will be, T will be 6, so that will be 6 squared, which is 36. So that is the first equation that you're going to get. Then the other one, when P is equals to 18, you have the constant A there. T is equals to 3, so B, T squared, 3 squared will be 9. That is the second equation. Then we can simplify these equations by, like the first one, we can multiply each term. We can multiply each term by 36, like that, by 36, by 36. And this will give us 216. This will give 216. So 216 is equals to 36a plus this will be b. That is the first equation. The second equation, you can multiply each of these by 9 to get rid of that denominator, that is 9. And this will give 18 times 9, 162 is equals to 9a plus b, like that. Then those are simultaneous equations with a and b. We can use elimination. You can see b is uniform, so I can subtract to eliminate b. So 216 minus 162, I will get 54. This will give 36. A subtract 9a, that will give 27a, and then b will be eliminated. And for this one, you get a to be 2. Substitute here. 162 is equals to 9a. A is 2, that 9 times 2 will be 18 plus b, and b here will be given by 144. 162 subtract 18, 144. So you have a, you have b. Now the question is, find t when p is equals to 11. Now after getting the constants of variation, now look at the equation. Now we have the equation as p is equals to a is 2 plus b is 144 divided by t squared. So we are supposed to find t when p is equals to 11. So when p is equals to 11, so we just substitute here. So p is equals to 11. Then you have 2 plus 144 divided by t squared. So from here, to solve this one, I can simply multiply this one by t squared, this one by t squared, and this one by t squared. And this will give 11 t squared is equals to 2t squared plus 144, like that. So take t squared on the same side, you have 9 t squared, because 11 minus 2t is equals to 144. So t squared is equals to 144 divided by 9, you get that on as 16. And therefore for this one you will get t, the square root of 16, you'll get 4 or negative 4. 4 or negative 4 when you get the square root. So that is the value of t. When you get the square root of 16, you get either positive 4 or negative 4. So that is how you're supposed to solve that question. Jane deposits 24,000 in a fixed account. After 4 years, the money accumulated to 45,000. If the bank paid compound interest of R% per annum, compounded semi-annually, find R. So in this question, R is the rate, and there are some things that you need to take note of, that this rate of interest is compounded semi-annually, meaning in 1 year there will be 2 interest periods. That is what I mean by semi-annually. So to solve this question, we're going to use the compound interest formula, and this is how it is. The compound interest formula: amount is given by principal, brackets 1 plus R, that is the rate of 100, then raised to power n, where n is the period. Now what you're going to modify in this equation, or in this formula, is the rate, because the rate is compounded semi-annually. And also look at the years, you have to change that. So because in 1 year there are 2 interest periods, so what about 4 years? So 4 years will have n is equals to 4 times 2, because this one is compounded semi-annually. So that means in 1 year there are 2 interest periods. So what about 4 years? There will be 8. So n will be 8. Then the rate, we have to multiply the rate by a half, because it is earned for every semi-annually. That is every year twice. So once we do that, we can identify A. Accumulated amount is 45,000. So A is 45,000. 45,000 is equals to the amount deposited, the principal will be 24,000, and then 1 plus the rate will be rate divided by, you multiply this by half, you get 200, and then the period, we say that will be raised to power 8. So that is the most important thing you're supposed to do. So the rate, check the rate semi-annually, you multiply that by half, and then the period, 4 years, because semi-annually there will be 8 periods, 4 times 2. So once you've done that, because you want to get R, you simply make R the subject, because that is what you're looking for. So start by dividing both sides by 24,000. So get 45,000, divide both sides by 24,000, like that. I will remain with 1 plus R over 200 raised to power 8. So 45,000 divided by 24,000, that will give 1.875. 1.875 is equals to 1 plus R over 100, not over 100 but 200 raised to power 8. So the other thing is to get rid of that power 8. How do I get rid of that power 8? I will simply get the 8th root of both sides. So get the 8th root of both sides. So we shall have the 8th root of 1.875 is equals to, when you get the 8th root of the right hand side, you know you are trying to eliminate everything so that you can remain with r. So you'll get that. That is what you're going to get. So the 8th root of 1.875 will give 1.082. And then this will be 1 plus r over 200. So the other thing, you can take 1 to this side so that you can have 1.082 subtract 1 is equals to r over 200. So this will give 0.082 is equals to r divided by 200. So to get r, you simply multiply both sides by 200. So this will be 200 times 0.082, like that. And these will give 16 and 2 over 5%, or you can give it as 200 times 0.082, 16.4. Using a ruler and a pair of compasses only, part A, draw a line AB is equals to 6 centimeters and show the locus of a point P such that APB is equals to 60 degrees, 2 marks. Then part B, mark 2 points X and Y on P such that the area of a triangle ABP is always 12 centimeters. Now to begin with, you need to ask yourself which type of locus is this that you require to draw. You require first, you can just do a sketch here of the requirement, what you need. So you have line AB, which you're going to construct, that is 6 centimeters, and you require the locus of a point P such that APB, P can fall either above that line or below that line. APB is always 60 degrees. So this is constant angle loci, and the concept that you're going to use is that concept where in a circle, that the angle subtended by the same chord at the center of the circle is twice the angle subtended at the circumference. And therefore, since we want the angle at the circumference APB to be 60, we will have to construct the center of that circle to be there, so that we have this angle here, because the angle at the center will be twice, to be 120. And then we use this one at the center, and we shall draw, using that we shall draw the locus of P. So the locus of P will fall anywhere along this arc. That's such that any angle that you form from A to the circumference and B, that angle will always be half of that, half of 120, which will be 60 degrees. So therefore, because this one is the radius, and this will be the center of the circle which you're going to use to draw that arc from A to B, we shall have this one as 30 degrees, and this one will be 30 degrees, since this one is an isosceles triangle. We also need, because P can be anywhere above, either above that line or below, we'll be required to do the same on the other side as well, whereby we shall have 30 degrees there and 30 degrees there. Then this one being the center, we shall also draw another arc there, and this arc, any point line on this arc will also be P. So ABP, P, the locus of P will be either on this arc that is above line AB or the one that is below line AB. So that is what we need to do accurately now. So we can go to the actual drawing. So we start by drawing line AB, where AB is 6 centimeters. So we measure 6 centimeters. I will use my pair of compass. It is calibrated. You can use your ruler as well. So standing at A, I need 6 centimeters. So measure 6 centimeters. So 6 centimeters will be, so that is 6 centimeters. So that is 6 centimeters, like that. So can mark an arc there, and that will be point B. So A will be here and B will be here. So now I need to construct, from there I need to construct an angle of 30 And to construct an angle of 30, first I will need to construct 60 degrees at A. So constructing 60 degrees at A, you construct 60 degrees at A. This is how you construct an angle of 60. So you just open any radius, you mark an arc there, and then with the same radius, you stand at that point, and then you cut that arc. So when you join these points here, when you join this point, you will have this one as that one is 60 degrees. So you bisect it, bisect that 60 to have 30. So how do I bisect? I stand at this point here, arc. So using any suitable radius of your choice, so you can mark an arc there, and then stand at this point here, then cut that arc. Then from there, you can draw straight line from A to the point of intersection. So that angle is 30. So you've constructed 30 degrees. So that is 30 degrees. You do the same at B. So standing at B, construct 60 degrees at B. So stand at that point, any suitable radius of your choice. So let me construct, so you mark an arc. Let me use a different color here. So you mark an arc there, and then standing at this, constructing 60 first. So standing at that arc again, you cut that arc. So you have an angle of 60. So that is 60 degrees. So that is 60 degrees. Then bisect it. So to bisect it, you stand at this point of intersection here, and then open any radius, suitable radius of your choice. You mark that arc, and then standing at this point, you cut that arc. Need to be very careful to observe these arcs to avoid confusion. Then from there, join this point at B to the point of intersection of those arcs. The point of intersection of these arcs, like that. So this is the point of intersection of those arcs I'm joining. So you have now the center. This is the center that you're going to use. So standing at this center, standing at that center, standing at that center there, you can now construct. Then open it, open this pair of compass up to point where it touches A, like that point. Then with that radius, you can construct now the locus of P will lie anywhere along that arc that I'm drawing there. There's something wrong here. So let me repeat. So with that, with a slide, so that up to that point, so you draw. Yeah, now it is okay. It is very much okay. So you can see that arc that you're drawing now, the locus of P will lie anywhere along that arc that I'm drawing there, using that center there. So that one is okay. So once you do that, the next thing you're going to do from there, you do the same thing. So the locus of P will be anywhere along this arc. You do the same thing for the bottom part. So for the bottom part again, you will start by constructing an angle of 30. So standing at A, you construct an angle of 60 first. You have to construct an angle of 60. So you mark an arc there, then stand at that point there, then you cut that arc. That will be 60 degrees. That will be 60 degrees. So let me join this one. It is 60. So that angle will be 60 degrees. Then you bisect it. Bisect that angle. Get 30. So I bisect this. So I stand at this point, and then a suitable radius of your choice. You cut that arc. You mark that arc there. And then you stand at the other arc there, the same radius, cut that arc. So once you've done that, you can join now using a straight line. You can join this from this point here. You have bisected that, like that. So we do the same at B. Now that is 30 degrees. So this is 30 degrees. So you do the same at B. So standing at B, you construct 60 degrees. That may use a different color with confusion. So you mark an arc there. Then standing at this arc here, you cut that arc. The arcs are so many. Need to be very keen when you're joining. So let me join that to make 60 degrees. So 60 degrees will be here. That is 60 degrees. So you bisect that 60 degrees. To bisect that, you start at this point. Then open that mark an arc here, that, and then from there, stand on this point here, cut that arc, you're bisecting the angle of 60, then draw that line. The point of intersection of the two arcs is here, somewhere there. So again, this one is 30 degrees. So this angle here is 30 degrees. You simply construct 60, then you bisect it. Then the center now of those two lines are intersecting at this point. So standing at this point, standing at that point, this point here, and then extend your pair of compass until it touches point A, like that. And then from there you can construct another circle using that. So you can see the locus of P will also lie anywhere along that arc, anywhere along that arc that I've drawn there. So that is P. So locus of P can either be above that arc or any point here. Any point here. So now you have constructed any angle that you make. Remember, this is the center. This is the center that you're using here, and this one is the other center that you're using. So this is the center, and this is the center we used. So any angle that you make, and also remember that the angle that helped us, this angle here, will be 120, and this one is 30, this one is 120. So we are using that property. The angle subtended at the center of the circle by this chord AB, this angle subtended at the center here, 120, is twice any angle subtended at the circumference by the same chord, that is chord AB. So any angle that we make from A to the circumference, then to B, will be 60. So the locus of P is there. That is the locus of P, and also on the other side. Now that is what you're supposed to do. Now the other part B, mark 2 points X and Y on P such that the area of triangle ABP is always 12 centimeters. Now for that triangle ABP, remember we are using the base as AB. The base is AB. That is 6 centimeters, and you are required to get a triangle such that it is always 12 centimeters. So what we need to get is the height. So the height that you're going to use from line AB, the height of that triangle. So if you take a half, the area of a triangle is a half times the base. Base is known, but now we don't know the height that you're going to use, the distance from AB to where we shall have that point X and Y, which should give us 12 centimeters squared. So this is how we get that height. Half times the base times height. And so when you work out this one, you notice this will be 3h, so height will be 4 centimeters. So what it means, you're going to take the height of 4 centimeters from AB. So I will use, you can use a pair of compass to do this. So you can take the length of 4 centimeters from the ruler. So 4 centimeters is there. So that is 4 centimeters. So with 4 centimeters, you can stand at A, and then you mark where we shall have, that is where we shall have X. And then you go to B, you do the same, you mark, that is where we shall have Y. So X will be here, and then Y will be there. So you can join this point X and Y using a straight line. You can join X and Y using a straight line. So X and Y using a straight line like that. You can join it using a straight line like that. So point X and Y. You do the same for the other side. The other side is the same measurement. You stand at A, and then mark a point on that locus P. So X again can also be here. And then you go to stand with a pair of compass. This is a point B, and then mark an arc there. So this one, point Y, can also be here. Then you can join this one using a straight line. You can join that using a straight line like that. So let me join this one properly like that. Yeah, like that. And join it using a straight line like that. So we have point X. So point X will be here, Y will be there, and also X will be there, So this distance from A to this line, this distance is 4. So any triangle that you form with this base AB, its height will be 4. And once you use the height as 4, you always get the area to be 12 centimeters squared. The base will be the same, will be AB, so the height is what we are required to get. So the point X and Y should be there because of this distance being 4 centimeters. So we can mark it here. So this distance here, and mark it. So this distance is 4 centimeters, and that will be the height of that triangle. That will give us the height to be, the area to be 12 centimeters squared, using the base as AB. Given the points P, -6, -3, Q, -2, -1, and R, 6, 3, express PQ and QR as column vectors, and hence show that the points PQ and R are collinear. So the first thing you're going to do is to get the vectors given PQ and QR. So let us get the vectors PQ and QR. So this is how we're going to do it. PQ and QR. So PQ, we start with the PQ. Now to get vector PQ, we are going to take the position vector that is of Q. We write it in column form, which will be -2, -1. Then we subtract position vector of P, which is written in column form. It will be -6, -3. Then from there, -2 plus, this will be +6, this will be 4. Then -1 plus 3, this will be 2. So that is vector PQ. Let us express QR the same way. QR, vector QR. We take the position vector of R, which is 6, 3. Then we subtract Q, which is -2, -1, like that. We subtract this, you get, this will give 6 minus -2, that will be 8. Then 3 subtract -1, that will be 4. Now we've done that. We have expressed PQ, vector PQ and QR in column form. Now the next thing you're supposed to do is to show that the points PQ and R are collinear. What does it mean? To show that these points are collinear, it means that these points PQ and R, you are supposed to show that they lie on the same straight line. That is what you need to show. And what do you do to show that? You have first to show that vector PQ is parallel to vector QR. And to do that, you must show that one of the vector is a scalar multiple of the other. And this is what I mean. Showing that these vectors P, Q, and QR are vector scalar. There exists a scalar between them, that is PQ and QR. That means one of them is a scalar multiple of the other. So this is what you do. So you show that is a PQ is equals to K, that is a scalar that exists between the two vectors, and QR. So once you show that this vector K is common, then that will mean that vector PQ will be parallel to vector QR. So let us show that. We got PQ, vector PQ was 4, 2, like that, is equals to K, that is a scalar, and then QR is 8, 4. So the first one will be 4 is equals to 8 times K, that will give 8K. So for this one, K will be given by a half. Then the other one you pick is 2 is equals to 4 times K, that will be 4K, and here K will be also half. You can see we are getting the same value of K. So that means that these vectors are scalar multiples of each other, and therefore we can say that PQ is equals to K, which is a half, QR. By showing these, that there exists a scalar between these two vectors PQ and QR, then we can say that PQ is parallel to QR. That is the first thing that you show. Then the other thing that you show, that these points PQ and R are collinear, is that there is a common point. Look at this point. There is a Q and Q there. So Q is a common point in the two vectors, that is PQ and QR. So that is how you show that P, Q, and R are collinear. Write the expression 4 divided by 2 minus tan of 960, subtract 3 divided by 2 plus tan of 960. The first thing you're going to do is to express tan of 960 in the simplest form, and you're going to use the unit circle to do that. Remember the unit circle. So from the unit circle, where is tan of this 960 is it? So you notice that one will be located in the third quadrant. To be in the third quadrant. This is how we have 900, because you go the first round, this is 0, the first round. Then the second round we shall have 360. The first round you have 360, then the second you have 720. So from 720 you shall have 810 there, then 900. So 900 will be there, and therefore 960 will be in this quadrant, 960. And the tangent of 960 is positive. It is positive in that quadrant. So therefore, tan of 960 is equivalent to, if you get the acute angle, you'll get tangent of 960 subtract 900, and this will give tangent of 60. So therefore, tan of 960 is equivalent to tan of 60. So after now getting that, you should now get the tan of 60 in third form, and to do that we shall use equilateral triangle of sides 2. So that side is 2, this is 2, so this angle is 60, this one is 60, and this one is 60. Then we have the height, there. This height will be root of 3. So from this, tangent of 60 will be given by, you can use any angle here, you can use this one that is here at A. So tan of 60 opposite of adjacent, so this will be 1 and this one will be 1. So it will be root of 3 divided by 1. So this will give root of 3. So therefore tan of 60 is root of 3. So after getting that, now we can substitute it here. So we now have 4. We have 4 divided by 2 subtract tan of 60. We have already established this is a tan of 960 is the same as tan of 60 degrees, which is root of 3. Subtract 3 divided by 2 plus tangent of these. Of course, we are substituting that, so this will be plus root of 3. So from there, you can use any suitable method to simplify these. So I'll proceed and get the LCM of 2 minus root 3 and 2 plus root 3. The LCM will be 2 minus root 3 to brackets 2 plus root 3. So from there, here you'll get, you divide by, so 2 minus root 3, 2 plus root 3 divided by 2 minus root 3. So you shall have here 4, then 2 plus root of 3, then subtract. We have 3. Then this will be 2 minus root of 3. Just the same way we add fractions, that is what you're doing. So we proceed. So we open the brackets. This one will be 8 plus 4 root 3 minus 6, then plus negative 3 multiplied by negative root 3. That will give positive 3 root 3. Everything divided by, when you look at the denominator, this is the difference of two squares, and therefore this will give 2 squared minus root of 3 squared. All the same, you can actually expand it and you still get this answer. I'm using difference of two squares to work out this. You need to recall a plus b multiplied by a minus b. That is what I'm using. This is the same as a squared minus b squared. It's the same thing, where a is 2 and b is negative root 3, or it is root 3. So from here, like terms, so you have 4 root 3 plus 3 root 3, that will give 7 root 3. Then 8 minus 6, of course that one you get 2. And that one will be positive. So that is what we get in the numerator. In the denominator you shall have, this will be 2 squared is 4. This is 4. Subtract root 3 squared is 3. And therefore, this will give 7 root 3 plus 2. And this is the simplified solution. Find the center and the radius of the circle whose equation is 3x squared plus 3y squared. Subtract 12x plus 18y plus 8 is equals to 0. So you're supposed to find the center and the radius of this circle given the equation. So one observation that you note here, we can divide all through by 3. So I'll first begin by taking positive 8 to the right hand side. So that I have 3x squared plus 3y squared minus 12x plus 18y is equals to negative 8. I've taken positive 8 to the right hand side. Then from there, I can simplify this one by dividing everything by 3. So if I divide everything by 3 all through, I'll get x squared plus y squared. Subtract 4x plus 6y is equals to negative 8 over 3. Remember, you're dividing all through. You're dividing everything by 3. The next thing we're going to do is to complete these perfect squares. So I'm going to group them like this. So you have x. So we have x squared. Subtract 4x. So you have to complete that perfect square. Then plus y squared plus 6y plus, you have to complete that, is equals to negative 8 over 3. So let's complete this. So we shall have x squared minus 4x. So plus, to complete this, you get half of negative 4. Half of negative 4 is, that is half the coefficient of x. Half the coefficient of x. So that is half of negative 4. That will give negative 2. So negative 2 squared, you get 4. So that is what you're going to add there. Then plus y squared plus 6y plus, so this one you get half of the coefficient of y. Half times the coefficient of y, that will be 3. Then you square that. So half times 6, that is 3. Then 3 squared, you get 9. So that is what you're going to do. Is equals to negative 8 over 3. Now whatever you added here and here, you have to add it here. So you have plus 4 plus 9. You have to do that. Then from there, you can factorize these. X squared minus 4x plus 4. If you factorize that, you get that one will be x subtract 2 squared when you factorize that. And then y plus 6y plus 9. You factorize that, you get y plus 3 squared. Like that is equals to, add this negative 8 over 3 plus, this is plus 13, that will give 31. It will give 31 divided by 3. 31 divided by 3. So already that equation is in the best form that will enable us to get the center and the radius. So this is how you get the center and the radius. The standard equation of a circle is given as x minus a squared plus y minus b squared is equals to radius squared. So you can compare. You can compare a, where a, b is the center. That one is the center of the circle, and r is the radius of the circle. So you can compare from here. You can compare negative 2 is equals to negative a. So negative 2 is equals to, so negative 2. So negative 2 is equals to negative a. So a is equals to 2. And then you can compare this. Positive 3 is equals to negative b. And so for this one, b is equals to negative 3. So therefore the center AB will be 2, negative 3. So that is the center. Then compare the radius. So you have this, the radius. So radius squared is equals to 31 divided by 3. So radius, you get the square root to get the radius of both sides. That is the square root of 31 over 3. And this one will give the radius as the square root of 31 over 3. That will give 3.215 units. Ten students of Bukakunga Secondary School scored the following marks in a test marked out of 20. 15, 14, 12, 13, 9, 16, 11, 13, 12, and 17. Calculate the quartile deviation of the scores. So we're supposed to calculate the quartile deviation. This one is in group data. So first thing is to recall, how do we calculate the quartile deviation of group data? This is the formula we use. So quartile deviation is given by Q3 subtract Q1 divided by 2. What is Q3 and Q1? Q3 is the upper quartile, Q1 is the lower quartile. So the first thing you're going to do to get Q3 and Q1 is by arranging these values either in ascending or descending order. So I'll arrange this one from the smallest to the biggest, that is descending order. So let me do so. So arranging these, the smallest I can see is 9, then we have 11, then we have from 11 we have 12. I can see we have 12 values, 2, 12, 12, and then we go to 13, I can see there are 2, and you go to 14, then you go to 15, you go to 16, you go to 17. So I've arranged this one in ascending order from the smallest to the largest. The next thing you do, you divide these value set of data into 2 halves. So let me divide this one into 2 halves, and dividing it into 2 halves, I'll divide it up to that point. You can see to the left you have 1, 2, 3, 4, 5 values. Then to the right 1, 2, 3, 4, 5. Now to get Q3 is the median of the upper half. This is the upper half. So the median of the upper half, identify the median. So direct, the median is 15. So the median of the upper half is what we refer to as Q3, so which is 15. Then the median of the lower half, that will give, so this one is the lower half. The median will give Q1, that is 12. Now you have Q1 and Q3, so therefore quartile deviation is given by Q3, which is 15, subtract Q1 divided by 2. And this will give 3 divided by 2, which is 1.5. Three athletes, Ken, Dottie, and Mbugua, are in a race. Ken is twice likely to win as Dottie, while the probability of Dottie winning is 1/3 that of Mbugua winning. Find the probability that A, Mbugua wins the race, B, either Dottie or Ken wins the race. So let's go to the first question, probability that Mbugua wins the race. So you given that Ken is twice likely to win as Dottie, while probability of Dottie winning is 1/3 of Mbugua. So I will start by letting the probability of Mbugua winning to be represented by X. Then we have Ken, and then we have Dottie. So Ken is twice likely to win as Dottie, while the probability of Dottie winning is a third that of Mbugua. Because we have already let Mbugua, probability of Mbugua winning to be X, Dottie will be a third of Mbugua winning. Mbugua winning, that is a third of X. And then Now we can go to the first statement. 𝐾𝐁 is twice likely to win as 𝐷𝐷𝐄. 𝐾𝐁 is twice likely to win as 𝐷𝐷𝐄. So this will be 2 multiplied by 𝐷𝐷𝐄, that is a third x, and this one will be 2/3 x. Now we have the probability of all of them winning, that is Mbogwa x, then 𝐾𝐁 2/3 x, and then 𝐷𝐷𝐄 1/3 x. Now the question is find the probability that Mbogwa wins the race. What is going to help us here is the fact that when we add, we get the sum of all these probabilities. That is the sum of probability of Mbogwa winning and 𝐾𝐁 winning and 𝐷𝐷𝐄 winning. That should give 1. The probability of the three of them, if you add, we are supposed to get 1. So we add x plus 2/3 x plus a third x, and that will give 2x is equals to 1. So therefore you get x to be a half. So if x is a half, then that is the probability of Mbogwa. Remember, probability of Mbogwa was x, so the probability of Mbogwa winning is a half. Then 𝐾𝐁 will be 2/3 times x, that is 2/3 times a half. So this will be 2/3 times a half. This will be 2 divided by 6. 2 divided by 6, and you can simplify that one to a third. So that one will be a third. That is the probability of 𝐾𝐁 winning. Then 𝐷𝐷𝐄 is a third x, so this will be a third times x, which is a half. That will be 1/6. So now we have the probability of Mbogwa winning, which is a half, probability of 𝐾𝐁 winning, which is 1/3, then probability of 𝐷𝐷𝐄 winning is 1/6. So we have already answered the question. The first part is Mbogwa winning the race, so probability of Mbogwa winning the race will be given by a half. Part B, probability that either 𝐷𝐷𝐄 or 𝐾𝐁 wins the race. Now for this one, you have two options. You can decide to use a tree diagram, or you can decide not to use the tree diagram. So I will not use the tree diagram in this question, and this is what I'm going to do. So since you want the probability of either 𝐷𝐷𝐄 winning or 𝐾𝐁 winning, this one will be given by, remember the sum, even if you draw the probability tree diagram, the sum of all the probability will be represented by 1. So if you take the sum of the probability of the three of them to be 1, then you subtract the probability of, because you want only where 𝐷𝐷𝐄 and 𝐾𝐁 wins to remain with that, so you're going to subtract the probability of Mbogwa. Probability of Mbogwa not winning, I will represent that by m prime, then plus the probability of none of them winning. So when I do that, I will simply be left with the probability of either 𝐷𝐷𝐄 or 𝐾𝐁 winning. So 1 subtract the probability of Mbogwa plus the probability of none. When you subtract that, we'll get the solution. So we already have the probability of, I can list them here. So probability of Mbogwa winning will be a half. So Mbogwa not winning, the probability will be also a half. Then for 𝐾𝐁, the probability of 𝐾𝐁 winning is 1/3. So probability of 𝐾𝐁 not winning will be 2/3. Then the probability of 𝐷𝐷𝐄 winning is 1/6. Then probability of 𝐷𝐷𝐄 not winning will be represented by 5/6. So we already have the probability of Mbogwa not winning is here. Mbogwa not winning is here. Is there. So we get 1 subtract probability of Mbogwa not winning, that is a half, plus probability none of them wins. None means the probability of Mbogwa not winning, 𝐾𝐁 not winning, and 𝐷𝐷𝐄 not winning. So this one will be given by Mbogwa not winning, that is a half, multiplied by 𝐾𝐁 not winning, that is 2/3, like that, and then times 𝐷𝐷𝐄 not winning, 5/6. like that. So this one, when you work it out, you get 1 subtract, so you get a half. This will be a half. Then plus, when you take a half, you take 2/3 times 5/6. That will give 10 divided by, that is 6. Like that. So, and this one will give you, when you subtract these using a calculator, you get this one to be represented by 2/9. So 2/9 is the solution. The figure below shows a circle with chords PQ and RS. A point X lies outside the circle, as you can see in the diagram there. Part A of the question: construct a tangent from point X to touch the circle on the upper side at point B, 2 marks. Part B: measure the size of angle AOX. So the first thing you're going to do is to locate the center of the circle. And how do you do that? Given these two chords, SR and PQ, once you draw the perpendicular bisectors of those two chords, the perpendicular bisector of SR and the perpendicular bisector of PQ, they will meet at the center of the circle. Once we identify the center, we proceed from there. So let's first do that. So we get the perpendicular bisectors of SR. So you stand at S. Then with any radius of your choice, make sure you open this one more than a half of these. Of course, it should be more than a half. That radius, so standing at S. Then with that radius, more than half of that line SR, you mark an arc. And then you mark another arc there. Then you stand at R, then at R you cut that arc, and then you cut that arc there. So you cut those arcs. Let me go back. So with that, again, you cut that arc there. So from there you can join this one using a straight line, join the point of intersection of these two chords. So that point of intersection there, using a straight line like that. So that would be the perpendicular bisector of SR. Then you draw the perpendicular bisector of PQ. So to do that, stand at P. Then with so that is P, opening that one more than half of that line. Again, you mark an arc here, an arc there, and then you also mark another arc there. So let me make this arc to be a little bit bigger. So mark that arc. So again, standing at Q, you cut that arc, and also you cut this arc here. Then join this point of intersection of the two arcs using a straight line like that. So you can see where the two perpendicular bisectors are meeting. They are meeting at that point. So that becomes automatically our center. The center of the circle is obtained that way. So let me join now the center of the circle here to X. That is where you proceed. How we proceed now. Joining the center of the circle. All these are center. The center is O to X. Let me join it properly. So join it. Sorry. So let me join it. So you join it like that. It is okay. So this is the center. This is the center of the circle. Now from there, now we want to mark you construct a tangent from point X, touch the circle on the upper side at point A. Now let us identify. To do that, look at that line OX that you've drawn from O to X. Draw a perpendicular, or construct a perpendicular bisector of that line. So let us construct a perpendicular bisector of that line. So standing at O, you want to construct a perpendicular bisector of that. Open that on more than half of that line, and then you can mark an arc at the top there. In the same radius, you can mark another arc at the bottom here, like that. You can mark the arcs like that. Then you stand at X, then cut this arc, cut that arc, then also cut this arc here, cut that arc. So join these 2 points using a straight line. That's how you do it, using a straight line like that. So that is the perpendicular bisector of OX. Then once you've done that, this is how now we mark point A on the upper side of the circle. So you get this distance from this point. You can call this point M, that midpoint there. So take OM, that distance, measure that distance. So from O to M, take that distance there. So from O to M, after taking that distance, you stand at M with that distance from O to M, then cut that circle at that point. That is where you shall have your point A. And in case you require to have 2 tangents, you can cut the other side, but you don't require that for now. So look at this point where you've already marked. So this point here will be A. So join that point using a straight line from from X, you draw a tangent touching at that point. That is a point A. So here we have point A. Point A is there. So point A is here. That is why you have point A. Then you have O there. We have X there. So we've done that. We have constructed a tangent from point X, from this point, to touch the circle on the upper side at point A. We've done that. Then measure the size of angle AOX. AOX is this angle that is here. AOX. So take a protractor, you place the center there, and that angle will be, you measure that angle from this point. So from this side up to this point here, this will be 75 degrees. So you get 75 degrees. So measure angle AOX. AOX is equals to 75 degrees. So that is how we solve that question. The 16th term of an AP is 7 times the 8th term. The sum of the first 10 terms is -35. Find the first term and the common difference. The first thing you're going to do is to write the 16th term. And to write that, you need to recall at the nth term of any arithmetic progression. So the nth term is written as A plus n minus 1d. So therefore the 16th term, n will be 16. So when you substitute that, A is the first term, D is the common difference, this will be A plus 15d. Then the 8th term will be written as A plus 7d on AP. So given that the 16th term, which is A plus 15d, is 7 times the 8th term. The 8th term is A left hand side, I have a minus 7a is equals to 49d minus 15d. So these will give negative 6a is equals to, this will give 34d. Making a the subject by dividing both sides by negative 6, you get a is equals to negative 17 over 3d. So that will be the first equation. Now from there, we also do the next statement that the sum of the first 10 terms is negative 35. So you need to understand how do you get the sum of a number of terms, let's say n. This formula, and divided by 2, this is 2 brackets 2a plus n minus 1d. So when you're getting the sum of the first 10 terms, remember to substitute n with 10. So when you substitute the right hand side, that is n divided by 2, that side, n is equals to 10, you will have 10 divided by 2, that will give 5, is equals to, not is equals to, but 5, okay, multiply by 2a plus n minus 1, n minus 1 will be 10 minus 1, that will be 9d. So I've substituted the right hand side, and this one should give a sum of negative 35. So what I've done, I've simply substituted where we have n there, and that is what you get there. N is equals to 10. So this will be the first equation. We can open this bracket, we can leave it like that. So when you open it, you'll get 10a plus 45d is equals to negative 35. So now you have the first equation, which was here, you got a. The a is that, and the second equation, that is the second equation. This is the second equation. So solve these two simultaneously. So that one and that one can use substitution. So let me use this one because it looks easier. So 5 brackets 2a. 2a is 2 times a is negative 17 over 3d, then plus 9d, like that, is equals to negative 35. So this will give 5 multiply by, so this will be 2 times negative 17 over 3, that will be negative 34 over 3d plus 9d. So everything inside that bracket will give you negative 7 over 3d. So when you work out everything inside that bracket, you get that is equals to negative 35. You get it like that. So this will give negative 35 over 3d is equals to negative 35, like that. And making d the subject, so d will be given by negative 35 times 3 over negative 35, that will give 3. So you'll get 3. So when you work out these, you'll get d to be 3. So if d is equals to 3, so what about a? Remember a is here. So a is equals to negative 17 times d, which is negative 17 over 3 times 3, which is d. So a will be given by negative 17. So a is equals to negative 17. That is the first term, and the common difference is given. So you've given the first term, which is negative 17, the common difference, which is 3. In an experiment involving two variables, t and r, the following results were obtained. So they're there in the table, t and r. On the grid provided, draw the line of best fit for the data. Then part 2, using the graph, find the law connecting t and r. So let's go to the first part where you're supposed to draw. So I will plot on the x-axis, I'll plot t. So plot t here. So t will be there, and then on the y-axis I'll have r. So let me look at the value so that I can decide on the scale. So for t, you can see the smallest is 10, 35. So I can use 1 centimeter represent 5 for that. That would be okay. So 0 will be there. This will be 5, 10, 15, 20, 25, 30, and 35. Then for the y-axis, for r, you have 15, 10.5. So we can use 1 centimeter represent 2 for that. So 2, 4, 6, 8, 10, 12. You see the biggest is 12.5, so I can go up to 14 like that. And then 14, see 15, so you can go to 16, that point. So after doing that, now we can plot. The first one is when t is 10, r is 15, so 10, 15. So 10, 15. So should know the size of one small square. So 10, 15 is there, somewhere there. And then we have 15, 14. The next one is 15, 14. 15, 14. So 14 is here. So that is a point. And the next one is 20, 13. 20, 13. So 20, 13 will be in the middle here. Mark it properly. Be there. Then the next one is 25, 12.5. 25, 12.5. So the size of one small square is 2 divided by 0.4. So 25, 12.5 will be, this is 12.4, 12.5 will be somewhere there. There. Then 30, 10.5, 30, 10.5, these are 10.4, 10.5 will be there. Then the last one, 35, 10, 35, 10, 35, 10 is there, 35 is 10 is there. So now we can draw the line of best fit. So the first one, I think the first one, the way you plotted it, the first point, let me go to the first point. The first point was 10, 15, 10, 15, this one, 10, 15. So let me look at that. 10, 15, 10, 15 was supposed to be somewhere here. 10, 15 supposed to be here. I think I made a slight error there. So 10, 15 supposed to be there, around there. So we didn't have a point there. So now you can see all the points. The points are there. So you're supposed to draw the line of best fit, or the line of best fit. So we draw it. So trying to look at this point. So we have these points here. So try to check that line is passing through all the points. That let me see. I think that would be the best line. So I can extend it. When you're drawing the line of best fit, ensure that when you draw a straight line, majority of the points that you plotted are the ones that are lying on that line. So when I look at these, I try to draw here. So when you look at that line, just have a look at that line that I'm drawing there. So that line is passing, trying to look where we have majority of the points. So majority of the points. So yeah, look at that. So that I have at least 3 points, almost 4 or 3. So when you look at that line that I've drawn, you can see how many points? The ones that are lying on a straight line, you have 3 points. We have 10, 15. We have 15, 14, and we have 20, 13. Those points are on that line. So that is the line of best fit, whereby you find you've drawn a line and most of the points are lying on that straight line. The ones that are left, we only have 3, and when you try to draw any other suitable line using the point that I've plotted, you notice the one that will have majority of the points plotted being on that line is the one that I've drawn. It has 3, and that is the line of best fit. Now after doing that, we can use the graph to find the law connecting T and R. So the law connecting T and R. So the equation of this line, whereby, I'm treating this one as T, this is like X, and this is like Y. So if you want to get the law connecting T and R, you simply like writing the equation of that line. The general equation of a line, the standard equation of a line is given by this equation. So what do you need to get that line? You need the gradient, and also you need the y-intercept. So the gradient of this line, that is the first thing you're going to have. And when you write the equation will be R is equals to M T plus C. So what you're interested with is the gradient, and then we have the y-intercept. That is what you're supposed to get. So let me get the gradient. So get the gradient, you simply need to get 2 points on that line, and I will use 2 points on that line, lying on that line of best fit, like 10 and 15. So use 10 and 15, and also I can use 15 and 14. 15 and 14. So using these 2 points, I can get the gradient. So gradient is equals to change in y, and use 15 subtract 14 divided by change in x, 10 subtract 15. So this will give, 1 divided by, so this will give 1 divided by 10 minus 5, and this will give negative 0.2. So that is the gradient. So upon getting the gradient, now you can get the y-intercept. The y-intercept is simply the point where this line cuts the y-axis. Remember, this is the y-axis where you have R. So this point that is here, that is the one that is giving the y-intercept. The y-intercept, and that point is the mid of this line is around 17. So this 16.4, 16.8, around 17. This point is around 17. So therefore, the y-intercept is 17, and the gradient is negative 0.2. So therefore, the law connecting T and R is equals to M, negative 0.2, plus the y-intercept, which is, this is a T should be there, then plus the y-intercept. So that is the law connecting T and R.